to another class with me. My name is Ming. Today we're going to look at how to solve this question, and I'm going to assume that this is going to be a paper 2 with access to GDC, right? GDC is allowed. So how do we find this? First of all, we need to find this intersection, and here I've written down the value of the intersection here. Let us confirm that the intersection actually is this. So in order to find the intersection, I need to put in the function. So f1 in this case is my sine. So make sure you go put in sine, and then in here you put in 2x, right? And then make sure that the angle here is radian. If this is not radian, please make sure you change it to radian using the document setting, right? So if you go to document setting, you can change the angle to radian. And this is float of 6 values. In fact, I can increase it to float 12, right? And then make this as default, for example, say okay. And then F2, I'm just going to put in 0.6, right? This is the second function. First function is not been plotted yet. So let me go back to my graph function and then go back up to, so first function is sine. So trigonometry, sine, and then put in 2x, right? And then ensure this is still radian. Yes, it is. So press enter. And then next, I'm going to put in menu again, graph entry, function, and then this is just 0.6. And you can see that I have a lot of stuff. I don't need this. If you look at it, I'm only interested in the first hump, right? So we will then go to change the window setting. For example, it's going from negative 0.5 to up to about 4. I think that would be enough. And then y minimum is negative 1.5 to maximum 1.5. I think that will be adequate. So this is what we see now. I now need to find the intersection here and the intersection there. So now I go to menu again, analyze the graph and then use 4 for intersection. Go to lower bound, that is before the intersection. So over here like that, and then after that, I'm sorry, let me do this thing properly. Okay, and then go across. This is one intersection, and then do next graph again, intersection over here, press enter, and then go across the second intersection, move the one on to the top so that it's easier to see. Now I need to this x value, x coordinate, by saving it. So for example, I can save it to sorry, let me save this again. Save not the whole thing, just the x. All right, and then the store it and put in the variable a here, right? Now it's become highlighted. Same thing here, and then store this. So I also need to store this. Let me do this again. Store. Now into, let's call this B, right? So A and B. And you can also store by using control var to store a value. So that's why I have 0.3217 and 1.429. And here you can think about first rotating this thing about the x-axis so that we get something like a ball, right? It looked like a ball with the ends cut off, and then minus this cylinder. This is my x, this is y equal to 0.6, and if you rotate it, you get a cylinder. So basically what we need to do is that we get this kind of like ball thing or beads, and then hollow out a cylindrical hollow from the beads. So the volume now is going to be this pi, you put it outside, and then it's from 0.3217 to 1.249 ... and the function here is sine 2x square, and then minus this one, which is 0.6 everything square, and then dx. This is it. So right now I can use the GDC to solve this. So in order to use GDC to solve it, I would suggest that you use the Scratchpad and then go to Menu, go to Calculus, and then Numerical Integral, and then now go outside the integration sign and put in the pi, and then lower bound is a, so put in a, upper bound is b as we defined, and now I put a big bracket. All right, and inside there are two more brackets, minus, and the first one is going to be my function, so go to vars, and this is going to be f1 x everything square, and minus vars f2 x, and then everything square, and then out here dx. Press enter. So this is what I get. The answer is roughly 1.16 to 3 significant figure. So B here is 1.16 to 3 SF. All right, that's it. Now, if you're going to rotate this around 0.6, the second one, then you can think of it as rotating just here. So these become the new, now you get like a rugby ball, right? Like a rugby ball, and over here, each of these slides with this particular radius. This radius here is this, y minus 0.6. Therefore, what I'm going to do now is that the volume now of this rugby ball is going to be equal to pi, integrate from 0.3217 dot 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 to 1.249 dot dot dot, and then inside you will have y, in this case is sine 2x minus 0.6 everything square dx. And this volume here, you can see that it is possibly larger than this particular tube. I don't know, but we need to calculate it. So now I use my GDC now. So if you use your GDC, so I will now do menu again, calculus, numerical integral, make sure I put the pi outside of the integration sign. Here is my upper limit is b, lower limit is a, big bracket, this is going to be dx, and then put in another bracket inside, and then in there I'm going to put in bars. This is my f1 x, and then after that minus 0.6, or you can put in f2 x, and then after that to the power of x to the power of 2, right? Everything squared. And then now I press enter to get the answer 0.243 example. So the 3 significant figures, this is 0.243 cubic unit, 3SF, 0.21. And you can see that this is the bit. It is the volume here is smaller than what we obtained from getting a hollow bit. You can think of this as a hollow bit. This is the ball with a cut ends and a cylinder through it. All right. So you can also think of this as a bit with a hollow. This one is a bit without a hollow. So that's it, folks. Thank you very much.